introduce Clark Haynes, who, just as a little anecdote, was one of the first undergraduates that I got to work with while I was a Code Lab PhD student. So Clark, take it away.
Thanks. I will trust you can all hear me and see this great. I apologize. I came down with a cold this week. I was really looking forward to being there with all of you. But yeah, I have the unique pleasure to reflect on about a dozen years and many different stages of Code Lab. As Noah mentioned, I started as an undergrad with Noah, but went on to do grad school with Al, working on those climbing robots, and did a postdoc with Dan after he came to UPenn. So I got to experience, a transition from Michigan to Carnegie Mellon to Penn, and really wanted to reflect on my time at all of those places and then how that's impacted my career ever since. Let's see. So starting off with a little joke, some of you might recognize this. This was our lab password about 10 or 15 years ago. I really hope it's not the password still. Shame on you if it is. But what did this stand for? Legs are better than wheels 100%. And why is this? Oh, we just loved legs. I got to play around with Rex when I was an undergrad, during grad school, working with various generations of the Rise robot. And then during my postdoc, we really brought Rex back and did a lot of kind of system development to make new robots, things that we were just never afraid to build robots, and had a ton of fun. But it starts with first steps. These pictures on the left makes this seem a lot older than it really was. This was only the year 2000, but I think Noah was working off of, donated robot parts and whatnot from the 80s. So it was some really old hardware, but I got my start as just, a lowly undergrad working with Noah, learning about Jacobians from Noah and Dan, and, having philosophical discussions with Dan about what does it mean to program work, and then going back to the lab and, playing around with MATLAB extensions, C programming to interface these frame grabbers, and computer vision, getting my start. I had a ton of fun. I came back the next summer and worked with these early prototypes of Rex with people like Gabriel and Ulich and others, of kind of starting to program simple computer vision tasks. But that really helped launch my career, and I made the transition to Carnegie Mellon, where I joined Al's lab. And we started kind of playing around with robots of all forms. And I did a lot of project work. I've always been an engineer, did a lot of project work in those early years. But I think this was probably the first video that kind of got the start on my personal thesis. And once again, one of the themes that we keep coming back to is phase regulation. And what we see here is a Rex robot that can walk with an alternating tripod. It can climb with, I believe, Bob, correct me, a metachronal gait was what we called it, to go up the stairs. And previous engineers had sort of engineered a method for it to go from walking to climbing. And Al and I sat down and said, no, we should be able to do something better. So we made this kind of gait transition where we applied phase regulation, and we made the robot nestle its way into these stairs. And it never stops forward progress. It's always progressing, but somehow the legs adapt to the terrain and it just keeps going. And this kind of got started on what eventually became my thesis research. Of course, we had lots of project work. And as Al mentioned, we had this climbing robot, and I started playing around with a lot more gait control, very influenced by Al and Dan and their work with phase regulation. And we made that robot that climbed the library wall. Another anecdote on that story, the manager of the test location, Swery in San Antonio, Bill McBride had, he laid out that tarp, which you might be able to see a little bit of blue in that little picture, to catch our robot. But he also bet us that, he had this fancy German beer, and he bet us that we couldn't do it. And if we could climb the wall, we got the beer. And there's a picture of me drinking the beer. It was great. It was a little bit warm in San Antonio sun, but it was still great. But this really led to what became my thesis research. And again, phase regulation. But now we started thinking about obstacles in the phase space. And this was building, of course, on everything we've heard before, but also a lot on Eric Clavens' work of sort of multi-agent phase regulation. And so we learned how to design gates and how to switch between gates and then apply control laws to the gates. And I still really enjoyed those days, kind of getting that thesis together. I've always been more of an engineer than a pure scientist, but it was a great lesson in how to apply all these things. After that period of time, it was an interesting couple of years. Al had left CMU. He was at Boston Dynamics. I was kind of by myself at Carnegie Mellon, but pushed through with the thesis. But a lot of that really had a lot to do with Dan kind of coaxing me to make this scientific contribution, which is, hard when you're like a very lab work oriented engineer. But Dan convinced me to also come and join him for a postdoc after that. And I think our real scientific contribution during that postdoc was taking the kind of engineered, hacked up control laws that Al and I put together to make a robot climb a wall and really turning it into a language. And so we came up with these terms to really formalize the work we had done, built this concept of a gate complex, and really attached this to algebraic topology, and gave this language, and had some great papers out of that. And I'll come back to this about how this kind of thinking of the signals and symbols has really influenced my career. Of course, an engineer will be an engineer. I still love the lab work, and much to Dan's chagrin, I pushed that, we need to get our robots back up together. So we put together a lot of new robots. We completely re-engineered the guts of our robots and made some new versions, and we were able to go out and do lots of field testing. So I know folks like Aaron and many others, our trips to 29 Palms doing tests with the X-Rex robot, another version, a lighter version, X-Rex Lite, and then things that became Canid, which I know Jeff had many years working on, but squeezed a great thesis out of working on kind of sagittal plane bounding. And I really had a great time. I learned so much from Dan and from the lab of how to get these robot systems going. I think as kind of a testament to that investment we made in the kind of lab infrastructure, we were able to put out some of the first truly fully autonomous behaviors. So these are a bunch of animations of some of the work we did in the last year of my postdoc, particularly, with Aaron and Matt Hale. On the right here is a fully autonomous stairwell ascent. So we had LiDARs, IMUs, force sensors on the legs, and we were able to, program work in Rex to make it find stairs, approach stairs, and really compose all of these behaviors and get it climbing. And we didn't have to touch anything. The other videos are kind of simpler behaviors of force control on the legs to kind of get a statically stable stand on a rocky hill, and then kind of a gradient ascent hill climbing algorithm that just used the IMU and the natural, gaits of the robot to climb in a mountain in 29 Palms, basically. Tons of fun. But then, gave me a few moments to reflect on what made the lab special back then. And I think one of the things was we just put out incredible research across the full breadth of robotics and beyond. The beyond also included biology. It included biomechanics and topology, and really great connections, and how robotics really is the great connector of so many fields in science and engineering. But second, we were never afraid to make real world systems work. Even though Dan probably felt that we probably spent too much time in the lab, we loved our lab work, and we've always loved really being able to show that our work kind of translates to real world systems, and it's not just on paper. But the last thing was that our research team really tried to include everyone. From when I started out as an undergrad working with NOAA, I remember all the times that NOAA would sit me down and explain exactly out all of the terms in the Jacobian that mapped from camera coordinates to robot joint angle velocities and all of that. And I always felt so included in that. But then I got to turn around and as a postdoc working with Ryan Knopf and Matt Hale, and they were just part of our research team, making the robots and making the robots work. And we got publications with undergrads. And I think that was a really great reflection. I also want to spend a few minutes kind of talking about what I've been up to since. So I'll continue the joke. Legs are better than wheels, I think. In my first year after leaving sort of Dan's orbit, I couldn't totally escape Dan's orbit. So for another year, worked on a couple of projects. I was back at Carnegie Mellon working at National Robotics Engineering Center, and worked with Al as well on this robot on the left. This was LS3. And Carnegie Mellon was making a lot of the algorithms and systems for the sensor head that went on the front of the robot. And I got to tackle one of these little boxes in this diagram. It was a fun kind of introduction to being a more industrial R&D engineer, but still keeping those connections to great people like Al and other collaborators at Boston Dynamics and JPL. But I also had some time to do a grant that I was collaborating with Dan on to continue our studies of this canid robot, sagittal plane bounding. And, it had been, 11 years that I'd been in Dan's orbit. And this was the first time I really used a Lagrangian to make a model of a robot. And so here's a passive dynamic hopping sagittal plane bending robot with springs. So after that, I think one big reflection for me is all of our time doing robotics work in the lab and making big systems work really paid dividends for me in my career, because I jumped onto one of these big DARPA projects, the DARPA Robotics Challenge, which, as some of you may remember, Gil Pratt ran, very inspired by the Fukushima disaster of, could we be able to send humanoid robots or other robots into disaster scenarios and potentially make life-saving moves. And so at Carnegie Mellon, we developed the chimp robot. I had a great time. I learned a ton. I was leading the software development on this robot. And a couple just cool things out of that were, we came third place in the prize, made $500,000 for Carnegie Mellon. And I also got to visit Fukushima, which was just inspiring of where can we help the world in many ways. And fun fact, I got more radiation on the flight from New York to Tokyo than I did from visiting Fukushima. After that, wheels are better than legs. Please don't shoot me. I'm just making a joke here. Like many others at the time, I jumped into the autonomy industry. So joining Uber, working on self-driving cars, and worked in many different roles, but ultimately led the prediction efforts for our self-driving system. So this is really thinking about, you're in a world, there are lots of other things in the world. What's everything else doing, and how does that affect what you should do? And, again, learned a ton, really enjoyed kind of both the engineering side, but also mentoring and managing teams and learning a lot from everyone. Those were some of the, most interesting years of my career in many ways. And also had a cool experience of, going to TechCrunch Mobility and waxing philosophic about ethics for self-driving cars, which was fun. But I want to return to one point of, we talk a lot about phase regulation. And, when Dan and I made this formal complex for the gate complex, we used a piece of math called Young Tableau, where we could write down strict orderings of legs in a gate. And as we knew at the time, it has applications to many other things. And, that actually laid kind of an architecture for how we ended up building the prediction system for our self-driving cars. And in this figure is just a toy example of 3 actors on a road: a parked truck, a red car approaching that needs to pass the parked truck, and another car approaching in the other direction. And I'll leave it as homework to the listener, or just for Dan, to write out the Young Tableau. They do exist here. There are many different ways this scenario rolls out. I will say it was fun to kind of reflect on my time building regulation of phase for legs in a gate, and how that kind of impacted, the work I later did predicting the phase and regulation of phase for actors in multi-agent traffic coordination. But nowadays, these problems are all machine learning. So we use things like, Young Tableau to enumerate the scenarios, but then rest of everything is completely machine learning. And that's kind of the sausage in the sausage factory. But I wanted to jump to my last little vignette of how my experience in Dan's lab has affected my career since. Wheels are better than legs 100%. Again, just making a joke here. I don't actually mean this. But there's a little preview in these plots. So this right plot is one that Martin used a lot when kind of studying the energetic performance of Rex robots. And Dan and I later used it to, make a hacked up version that allowed us to measure the energy consumption of a climbing robot like Rise. And we really showed how Rise was just dismally inefficient at climbing. It was extremely slow and it took a lot of energy to do the work it did. But in the world today, with rising energy prices and concerns of carbon emissions for climate, we always want to think about how can we be more energetically efficient. And I think there's a preview here. Meanwhile, today, numbers released just this last week, the estimate for last year is that about 43,000 people died on our roads. And we really need to improve this situation. Like many others, I got into self-driving vehicles because of the promise to kind of solve traffic incidents. Unfortunately, I've spent enough time in the industry to know that it's still a long ways off to really impacting society at the sort of whole society level of radical reduction of traffic accidents. And so, I just kind of want to preview moving in a different kind of pivot. So the industry itself is pivoting in many ways. Some companies are still working on urban driving, but many have moved on to highway vehicles or delivery robots. And it makes you wonder, how are we going to save lives if all we do is put little robots on the sidewalk to deliver food? Meanwhile, traffic is getting worse and worse. These are numbers from the last decade of motor vehicles, but more alarmingly, bicyclists and pedestrians really getting killed on our roads in greater numbers than in a very, very, very long time. And so I decided to leave the self-driving industry late last year and started a new startup. We are officially still in stealth, but we'll be coming out with our first products later this year. So I'm excited to kind of share a little bit with all of you. But it's owing back to many passions of mine. I think most of you probably know that worked with me that I loved bike commuting. I've always loved bike commuting. And I remember parking my bike in various generations of Dan's lab over the years. And so, what am I working on these days? Well, it's taking an autonomous vehicle and turning it into like the world's smartest bike light. And I won't go into too many details, but Dan, young Tableau show up here too. In these traffic scenarios, you have vehicles that, they can do one scenario where they pass you safely, or they can cause scenarios where accidents might occur. And our goal with this new company is to basically predict these accidents seconds before they occur and use this to save lives of bicyclists on the road. How is this being done? This is just like putting together Rex many years ago of packing a bunch of sensors, putting in enough compute and batteries, and it really brings up the question, what is a robot? I think you can easily argue that a bike light is not a robot. But now once you start thinking about a bike light that has Kalman filters and deep learned perception systems and probabilistic decision making, it's truly a robot. So, just jumping into a couple of things of tiny packages, good machine learning systems. There's a lot you can do with this using the data. I don't want to go into too many details, but basically a strong belief that, robotics can affect urban mobility in many unique ways. And it's not just all going to be self-driving cars. We're going to be doing tons of other stuff. So if anyone's curious about this, I'm happy to chat with anyone. We're called Velo AI. Email me. Of course, if you ride a bike, email me and we'll beta test and play around with things. But where I wanted to end was just, maybe this should be the new lab password. Robots are awesome, 100%. Regardless of what your robot is, the ability to program work and affect change in the real world is one of the greatest things I personally learned from Dan and all of the work with Dan's many collaborators over the years. I do have one final reflection in this last minute. When I was a lowly undergrad, in year 2000, working with NOAA that first summer, getting a PhD was not in my worldview. It's not something I'd ever thought of. I was going to get an undergrad, maybe tack on a quick master's while at Michigan, and then head off to industry. And it was really kind of NOAA making the suggestion, hey, you should apply to grad schools. That first got me to really think that like, that is an interesting path for me. And, it's a path that, changed my career over the last 20 years. And I think it's important for us to reflect on, Code Lab back then was a bunch of white male engineers. And, I know that Code Lab today is not a bunch of white male engineers, but one reflection here is, diversity is always the goal, but the how is inclusion. And for me, who was a white male engineer with a, pretty good upbringing, it took Noah saying those words to me for me to feel included, to think, hey, I should go get a PhD. And maybe one thing to think about is, who are all of the people that we can be including and making certain that they see themselves as potential researchers, engineers, and scientists in the future who might not be the exact same as us, and how can we use that to kind of improve the world going forward? And I think that's one thing that I've seen change in the last 20 years, and I'm excited to see the change that will happen in the next 20 years. So yeah, that's the end of my talk. Thank you, Dan, and then thank you, everyone in Dan's orbit that helped affect my career, Noah, Al, and so many others. Truly sad I couldn't be there with you today, but really, thank you all for everything.